Hello everyone. In this class we will do the quick revision of current electricity formulas from class 12 physics for your NEET exam or board level exam. Okay. So look at the first type, that is formulas of current. So the simplest formula of the current is average current is nothing but delta Q by delta T, rate of change of charge by time. So current is scalar property, scalar, SI unit is ampere and the dimension is A1. Another formulas of current is Q by T, Ne by T, Nef or Nev by 2 pi r. And this is the instantaneous current. Next, look at the drift velocity formulas. This is the important part for your board exam and NEET. Drift velocity is nothing but the average velocity attained by the electrons under the influence of electric field. So the formula and relation between current and drift velocity is I is equal to NEA V suffix T. This is the relation between current and drift velocity. And the another relation between drift velocity and mobility is Vd upon E is equal to mu. So here the one question is there, if drift velocity is doubled, then what about mobility? So answer is remains same because mobility does not depend on drift velocity and electric current. Okay, so this is the trick. Look at the next part, that is current density. So current density is nothing but defined by current per area, I upon A. So if we want to write down current density in terms of drift velocity, it become NEAV because current is nothing but NEAVD. So if we divide by A, so this A will get cancelled. So it will be nothing but relation with drift velocity and current density J. And this is the vector form of current density. J is equal to sigma into E. This sigma is nothing but conductivity. And here is the important part. You can see that here this is a cross in non-uniform cross section area. This is non-uniform. So at this both the point A and B, the important thing is current remain constant. There is no change in the current. Whatever current is here, the same current will be here. There is no change in the current, but the remaining thing will change. Current density and drift velocity. That will be different in non-uniform cross section, but the current remains same. So this is the important point. Look at the next slide. So in this slide we have the conductivity, resistivity, resistance and voltage relations. So conductivity formula in terms of relaxation time is Ne square tau upon m. This tau is nothing but relaxation time. It is a time between the two collision of the two particles. So in terms of if you want to write down resistivity, resistivity is nothing but the reciprocal of conductivity. So if we apply this formula here, so resistivity is m upon Ne square tau. And the next thing is resistance. Resistance can be written as rho L upon A. This is the important formula. And if you apply the value of rho here, then resistance can be written as ml upon Ne square tau into A. And if you substitute the value of R in the Ohm's law, V is equal to IR, then we will get the formula in terms of V A M I. And therefore V is equal to IR. Look at the next important relations of resistivity, length and area. So resistance, the very important formula is R is equal to rho, that is resistivity, L means length of the conductor, A means area of the conductor. So resistivity is directly proportional to the length and inversely proportional to the area. Resistance, okay, and this resistivity that is depend on the material and temperature. So the here the very important table. If length is changed but area is constant, then resistance is directly proportional to the length. But if length is changed, like stretched and all, and volume is constant, in that case resistance is proportional to L square. Okay, so remember this. If you know this trick, then you can solve the question in a minimum time. The next part is if area is changed, length is constant, then resistance is proportional to the 1 by area. But if area is changed, like by stretching, and volume is remain same, then resistance is proportional to 1 upon area square. Okay, this is the very important thing. And one more thing, the resistance is proportional to the length square directly, and with mass it will inversely relation. So here one question is also there. You can see mass ratio is given 1:3:5, length ratio is given 5:3:1. So the ratio of the resistance we have to find out. So by using the formula, we'll get 125:15:1. The next part is resistivity dependence on temperature. So if we increase the temperature, decrease the temperature, then what will happen? So we have here three type of material. The very important part in conductor, okay, we have the formula of resistivity with temperature. So this is the resistance of the final temperature, resistivity. This is resistivity at initial temperature, inside the bracket 1 plus alpha delta T. So delta T means this is nothing but change of temperature, alpha is called temperature coefficient. So in case of conductor, if we increase the temperature, resistivity increases. So if resistivity increases, then conductivity decreases. And since temperature increases, resistivity increases, so this alpha is nothing but positive in case of conductor. So the graph of conductor resistivity versus temperature graph is like increasing. In case of insulator, the graph is like this. For example, this is a graph of nichrome. So temperature increases, resistivity decreases, okay, and the conductivity increases. And in case of semiconductor, okay, and one more thing, the alpha value is negative in case of semiconductor as well as insulator, and the result is also same for both. So temperature increases, resistivity decreases, but conductivity increases. In the graph of the semiconductor, uh, resistivity versus temperature is like this, decreasing. Okay. Only this in this insulator, the graph is like this, linear curve. And here one trick is given, that is, if equivalent resistance of two series resistor does not depend on the temperature, then this relation will work. And one more thing, this alpha, that is called temperature coefficient. So the SI unit of that is nothing but Kelvin inverse. And this is the direct formula. Suppose numerical will come and you have to find out the value of alpha. Then just do the thing, the change of this resistivity upon original resistivity and change of temperature. Look at the next part, that is very important for your numericals. Resistance connection, series connection and parallel connection. So in series connection, current is same but potential is different. So we are adding the potential like this V1 plus V2 and so on. So in series connection, resistance we have to just simply add. So suppose n equal resistors are there, identical, then the required resistance is nothing but n times that R. Okay. So जितना ज़्यादा resistance उतना ज़्यादा voltage drop, because V is directly proportional to the resistance. But in case of parallel connection, potential remains same and current changes. Current are different. So if we add the current, we'll get the resistance connection 1 upon required is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So if n identical resistance are given, then the net resistance, how to find R upon n. N means how many resistance are there, and R means the value of the resistor. Okay, so this is a important formula when identical resistance are given. So in case of parallel, jitna kam R utna zyada I, because we are adding by reciprocal. Okay, so in household circuit, matlab parallel circuit, because low resistance then high current, because current is proportional to the inversely to the resistance. So जितना कम resistance रहेगा उतना ज़्यादा current आएगा. Okay, look at the next part. So this is about battery. So while charging, the graph of the potential versus current will be look like this. So the formula is E plus IR. So you can see that by using the graph, the slope of this graph is positive. Slope is positive, so this small r is nothing but slope. If you compare with the mx plus c, the slope is positive. But while discharging, the graph will be like this, slope is negative. So E minus IR while discharging. Okay. And here one more important thing is Kirchhoff's law. So Kirchhoff's first law says whatever total charge is entering and whatever total current entering and leaving at the junction, the total is zero. So it is talking about the charge conservation. But the second law, that is loop law of Kirchhoff's law, that is based on energy conservation. Okay, so this is also important. First law is conservation of charge, second law is conservation of energy. The next part is on power. So rated power and rated voltage are given calculate to pure resistance. Okay, so power formula we have P is equal to V square by R. So to find out the resistance of the bulb, V square upon P. So resistance of the bulb is inversely proportional to the power, and this is the another important formula. Okay, this is very important formula. You can say uh, P constant is equal to secondary voltage upon resistor voltage whole square into power rated. Okay, otherwise, suppose two bulbs are there with a different power and we have to find out the resistance or voltage, we have to use this formula. So we can write down like this also: P2 is equal to V2 by V1 the whole square into P1. Look at the next one. Circuit combination. Okay, so if we connect the bulbs in series, so that is Buckwas combination, because in the case of series connection, power we have to add like this: 1 by P1, 1 by P2 and 1 by P and so on. So in this case जो कम P rated का होगा वो ज़्यादा चमकेगा, because here power is inversely proportional to the P rated. But in parallel combination we are just simply adding the powers, so here power is increasing, so here it is directly proportional to the P rated. So जो in the parallel combination जो ज़्यादा P rated का होगा वो ज़्यादा चमकेगा. So this is the trick in series and parallel combination, so remember for your exam. Next is time taken by heater coils. So heater coils is nothing but like a resistance type. In series we have to directly add up the time. In parallel we have to just if it is 2 only, then we have to just multiply and thereby addition. This 1 upon you have to add like that, reciprocal. How we are adding the resistance like that. The next part is how to convert galvanometer into ammeter. So to convert galvanometer into ammeter, we are just connecting one a small resistance that is called shunt parallel to the galvanometer G. Okay. In this case, the resistance is small, and to find out that shunt resistance, we have one formula: S is equal to Ig into G upon I minus Ig. This is the formula to find out that shunt. Okay. And here some short tricks are also given, so you can go through it. And the another last part is how to convert galvanometer into voltmeter. So by connected a large resistance in series, not parallel, a large resistance in series to connect galvanometer into voltmeter. And this is the formula to find out that S value. And in the last, meter bridge is nothing but 1 meter scale is there, and two resistance will be there here. For example, P and Q. Total length is 1 meter. So let's say the jockey is here. So this is, let's say, length L1. So the remaining length is 100 minus L1. So the formula to find out the balance condition of the Western bridge is, we can write down like this also: P by Q is equal to L1 upon 100 minus L1, or you can write down P upon L1 is equal to Q upon 100 minus L1. Okay. So these are all the important formulas for your exam. If you like this video, then do share, like and comment, and subscribe to watch more such videos. Thank you.